We're going to look at the laws of exponents rules again, and we're going to review all of them now because we're going to do some practice with a mix of everything. This lesson will be everything except for the product of powers rules, or the power to a power rule. All right, so basically when you're multiplying, you're going to keep the base and add the exponents. So when you multiply like bases, keep the base, add the exponents. When you're dividing like bases, you're going to keep the base and subtract the exponents, but you're going to keep the base where the higher exponent resides. So if that's in the numerator, your base will stay in the numerator and subtract the exponents there. If it's in the denominator, move your base to the denominator, subtract your exponents there. Anything to the 0 power, so example, t to the 0. All right, so anything to the 0 power always equals 1. Okay, anything to a power to power, okay, is going to be multiply the powers. So 2 times -4 would give you then a t to the -8. So the rule is that you keep your base and you multiply your exponents, power to power. Okay, we're not going to see too much of that in this lesson here because we've done that already, but just something to keep in mind as a review of all the rules. All right, and that takes us to our last one, which is our negative exponents rule. T to the -8 cannot stay that way, so what you're going to do is you're going to make sure that you move that base. So if that base is in the numerator, it moves to the denominator and the power becomes positive. If the negative exponent is on the base that's in the denominator, you're going to move it to the numerator and make the exponent positive. So it becomes t to the 7th in this case. So that's a quick review of all your rules, and now we're going to put them all to good use. All right, our next problem is going to be in multiplication of two quantities, all right? 2x squared, okay, times 4x cubed y squared. So rule of thumb is this. You're being multiplying these, you've got exponents involved. I always take my numbers, my coefficient numbers, and put them together. So that would be 2 times 4. Then I'm going to take my x's, because it's all multiplication. So I take my x squared and put that. So I've got this one done, this one done, and this one done. So I'll check them off. Okay. Then I'm going to take my x cubed and multiply that next to my x squared. Check that off that I have it. And then the only thing left to do is multiply by y squared. So check that off. So everyone has been accounted for, okay, every base. So now what we're going to do is 2 times 4 is 8. You're multiplying like bases here of x squared times x cubed. So you keep the base, you add the exponents, 2 plus 3. I'm going to show you that right now, but in the future we're going to get past that quickly and just do it. And then we still have y squared. You don't need multiplication signs between all of these. All right, so keep that in mind. So this becomes 8, x to the 5th, y squared. And that's our final answer. All right, next problem, jazz it up a tiny bit more. We're going to have the multiplication of 3 different terms, okay? So 2x squared z times negative 2x squared z times a -4y squared z times a -3xyz. Okay, so I'm going to bundle all my numbers together, all my coefficients. So -2 times -4 times -3. Check, check, and check. They're gone. I'm going to go to my x squared here. Got them. There's no x here, but there is an x here. Now this x has a power of 1. So I'm going to put the power of 1 so I can see it. And then I'm going to go through and I got a z. So I'm going to take that z here. Okay, it does not have to be alphabetical. So just keep that in mind. I'm going to grab him because I see him and he's a power of 1. So I'm going to put that 1 so I see it. I have another z here. And that's a power of 1 also. And I have another z here, which is a power of 1 also. And then I'm going to continue down here just because of space, okay? When we go through here, we still have a y squared. And we still have times y, and that's a power of 1 on this y. So I've got both of those. So everyone's taken care of. So now I'm going to multiply -2 times -4, which is +8. +8 times -3 is -24. So that's the coefficient. That's done. Then I'm going to take the x's. I'm multiplying 2 x terms, and I'm going to then add their exponents. So that's going to give me x to the 3rd power. Next, I'm going to work the z's. I have z to the 1st times z to the 1st times z to the 1st. So you keep the base, add the exponents, 1, 2, 3. So z is to the 3rd power. And then I've got y's. So I have y to the 2nd times y to the 1st. You keep your base, you add your exponents. If you want to, you can rewrite it in alphabetical order, but it's not necessary, nor is it, sorry, that's a 3, nor is it required. You can have these in any order. Just keep the coefficient in the front like we always do. All right, let's get into some division now, okay? We have 21, d to the 18th, e to the 5th, divided by 7, d to the 11th, e to the 3rd. Okay, so what we're going to do is we're going to space this out. We're going to keep the coefficient numbers here. D to the 18th, give a little room, put d to the 11th under it. E to the 5th, a little more room, and e to the 3rd under it, okay? All right, so what we do here is we say, all right, well, 7 divides into itself once, into 21 3 times. So in our numerator, so far we've got 3. Now, in division, you keep the base and you subtract the exponents where your exponent is higher, larger. 18 is the larger of the two exponents, so 18 and 11. So we're going to keep our base d in our numerator, and we're going to subtract 18 minus 11. I'm going to show you for this demonstration, and then we're going to just do it in the next few problems. All right, so these guys are done. So e is the next one. Again, we're going to keep our base where the exponent's higher. Our exponent's higher in the numerator, so we're going to keep e in the numerator, and we're going to subtract our exponents 3 minus 5. So in that case, you know, it's always going to be the highest number minus the lowest number of the exponents. And then there's really nothing left in the denominator because there's 1 there, so it's just a 1. So you can ditch that, and you can do 3. 18 minus 11 is 7, so d to the 7th. 5 minus 3 is 2, so e to the 2nd power. So your answer is 3, d to the 7th, e to the 2nd, or e squared. All right, now we really jazz it up because now we're going to put some multiplication in with the division. So again, same thing. Work through your numerator and your denominator and see if there's anything you can put together through the laws of exponents. And in this case, we can see we have an e to the 5th times e squared in the numerator. So let's simplify that. So let's keep the negative 40. And at the same time, we can space out a little because we can see there is nothing else we can do with s. All right, there's nothing to combine with in the numerator or the denominator right now. So we're going to keep the 40. I'm going to give some space, e to the 6th. And I'm going to calculate e to the 5th times e to the negative 2nd is e to the 5 minus a negative, plus a negative 2. Okay, because that's multiplication, so we keep our base at our exponent. So we're doing 5 plus negative 2. All right, 20 goes underneath our coefficient of negative 40. S cubed will go underneath our s to the 6th, and our e to the negative 6th will go here underneath this, e. All right, so now we're going to simplify. 20 goes into itself once and into negative 40, negative 2 times. So far in our numerator, we have negative 2. For our s's, our largest exponent for division is in our numerator. So we're going to keep s in the numerator, and it's 6 minus 3 for our subtracting our exponents. This we got to clean up. So this became e. 5 plus a negative 2 is 3, and we still have e to the negative 6th here. Okay? As you get better at it, you'll do these quicker. Like you'll kind of do that first, and you wouldn't have to do this in 2 steps, but that's okay. We'll do it in 2 now, so just see what we can do. Okay, so let's clean up. In our numerator, we have a negative 2. This becomes s to the 3rd power, 6 minus 3. We have a division, e to the 3rd divided by e to the negative 6th. 3 is larger than negative 6, so e will stay in the numerator, and it's 3 minus a negative 6. Be careful with signs. So that means that nothing's in the denominator but a 1, because we can't leave 0 in there, because that's not what's happening. We're dividing, so 1 will be left behind. So now we're going to simplify, and our final answer is going to be negative 2 s cubed. E to the 3 minus negative 6 becomes 3 plus 6, so e to the 9th. And that is our final answer. Negative 2 s cubed e to the 9th. Okay? All right. Got 2 more problems to work with you here, and we're going to go through them now a little quicker, a little simpler. All right, we have a to the 5th, b squared, b cubed, times c to the 5th, all in the numerator. We have a squared, b to the 4th, c to the 0 power, and c to the negative 2 power, all in the denominator. So I'm going to do some cleanup while I'm here. First of all, these guys, these b's in the numerator have to get multiplied. These c's have to be multiplied. All right, so it depends on how you're seeing it, so let's take a look. A to the 5th. B squared times b cubed is b. Keep your base, add your exponents. So 2 plus 3 is 5. And c to the 5th. In our denominator, we have a squared, b to the 4th, and then we have this. C times to the 0 times c to the negative 2nd power. Keep your base, add your exponents. 0 plus negative 2 is negative 2. Another way you could look at this is that c to the 0 is just 1. So that just leaves you c to the negative 2 anyway. So you have a couple ways to look at some of these. All right, let's work the a's. Division of the a's, a to the 5th divided by a to the 2nd. Subtract your exponents, keep it in the numerator because the 5 is larger in the numerator, so it becomes a to the 3rd power. Okay? B. This is b to the 5th over b to the 4th. 5 is larger, so we keep the b in the numerator. 5 minus 4 is 1. So that's the power on b. And c, 5 is larger than negative 2, so c stays in the numerator. 5 minus a negative 2, do it on the side if you need to, is going to be 5 plus 2, which is 7. And this would be a 1 in our denominator, so our final answer is a cubed b c to the 7th. If you wanted to write the first power on b, that's fine, but it is understood to be there, so you don't have to. And that's our final answer. A cubed b c to the 7th. And last problem. Okay. 6 r cubed t to the 0 t to the negative 4 s cubed over 2r t to the 7th s to the negative 5th. Okay, here we go. First of all, t to the 0 is a 1, so I just ditch it. Just get rid of it. It's not even worth doing anything with it. And there's nothing else in the numerator to combine by multiplication, nor the denominator. So let's start splitting apart. 6 and 2 go together. R cubed, R. Put the 1 on power on that R so you see it. That doesn't need to go anywhere because that's a 1, so 1 times anything is the anything. So we have a t to the negative 4. We have a t to the 7th in the denominator. We have an s cubed, and we have an s to the negative 5th in the denominator. All right, here we go. 2 goes into itself once, and into 6 3 times. So 3 is in our numerator. The r's. Dividing the r's, keep your base where your higher exponent is, which would be in your numerator. 3 minus 1 is 2, so r squared. The t's. Okay, the higher power for t is in the denominator, so keep t in the denominator. And 7 minus negative 4 is 7 plus 4, which is 11, so t to the 11th in the denominator. S's. The higher power is 3, not negative 5, so s will stay in the numerator. And 3 minus a negative 5, you can do that on the side. 3 plus 5 is 8, so s has a power of 8. So our answer is 3 r squared s to the 8th all over t to the 11th. So we'll write it again cleanly. 3 r squared s to the 8th t to the 11th power all over t to the 11th power, and that's it. All right, so that's simplifying using the laws of exponents with negative, 0, multiplication, division.